Happy day children, I hope you are all fine. This is our third video for Geography lesson 1 Interior of the Earth. In our last videos we saw about we recall the last videos. Okay, interior of the earth is composition of four spheres, that is lithosphere, hydrosphere, atmosphere and biosphere. And interior structure of the earth, we can divide the layers three types, divided into three types, that is crust, mantle and core. Crust is consist of only 1% in the total volume of the earth, and 84% consist of mantle and 15% consist of core. Okay, then we saw the plate movement, tectonic movement. The earth plates divided into two types, that is continental plate and oceanic plate. Continental plate is made up of silica and aluminum. This is also called as Sial, and oceanic plate is made up of silica and magnesium. It is also called Sima. Okay, so Sial floats over Sima, and the earth movement, the earth crust float over the mantle. Okay, so mantle is in molten form. Okay, yes, the plate movement, the earth movement is the main reason for the earthquake and volcanic eruptions. Okay, because interior of the earth, mantle is divided into two types, that is upper mantle and lower mantle. Upper mantle remain in rocks, but lower mantle is in molten form, and core, inner core and outer core is also in molten form. Okay, so the crust is remain rocks. Okay, so the molten rocks mantle, the crust floats over the mantles. Crust float over the mantle. So it is the crust is constantly in motion. Okay, the plates are constantly in motion. Okay, so the movement of the plate is the main reason for the earthquakes and volcanic eruptions. Okay, in this video we are going to learn about the earthquake. Okay, what is earthquake? Sudden movement of the we felt the sudden movement, shaking or trembling on the surface of the earth. Okay, that is called the earthquake. Okay, sudden movement of a portion of the earth crust which produce a shaking or trembling is known as earthquake. Okay, sudden movement of a portion of the earth crust, sudden movement of a portion of the earth crust which produce shaking or trembling is known as earthquake. Okay, the sudden movement, sudden shaking, trembling, we felt the sudden shaking on the surface of the earth, that is called the earthquake. Okay, what is the result of the earthquake? What is the cause of that? The earthquake may widespread damages, that means large amount of damages, destructions to the life and property where it occur. Okay, so the earthquake may widespread damages to the life and property. Okay, the point of where the vibration originate is called focus. Okay, the point of the earthquake starts. Okay, where the point starts, the interior of the earth, where the earthquake starts, that point is called focus. That point is called focus. Okay, the point of where the vibration originate is called focus. The point of the earth surface. Okay, the point of the earth surface, the surface of the earth, it is directly above the focus, it is called epicenter. It is called epicenter. Okay, the point of where these vibration originate is called focus. Okay, the point of the earth surface directly above the focus is called epicenter. Okay. From focus, the earthquake's vibration travels. From focus, the earthquake vibrations travels in all directions. Okay. From focus, the earthquake vibration travels in different directions. Travels in all directions. Okay. Travels in different directions in the form of seismic waves. These are called seismic waves. In the form of seismic waves. Okay. Three types of earthquake waves. The seismic waves are in three types, that is primary waves or otherwise called P waves, secondary waves or otherwise called S waves, surface waves or otherwise called L waves. Causes of earthquake. The chief cause of the earthquake is sudden slipping of the portion of the earth crust along the fractures or faults. Okay. The chief cause of the earthquake is sudden slipping of the portion of the earth crust. Okay. Sudden slipping of the portion of the earth crust. Okay. Along the fractures and faults. Okay. So, where the fractures and faults already found on the earth crust, the portion of the earth crust take sudden slipping. Okay. That is the main reason. Okay. And the movement of the molten rocks. The movement of the molten rocks. Already I told you the interior of the earth, mantle and core. The lower mantle and outer core are in molten form due to high temperature. So, the molten rocks underneath means below the surface produce the strains. Strains means force. Okay. So, it produce a force which break the rocks apart. Okay. So, the underneath the interior of the earth surface, the molten rocks create a force. It break the rocks on the earth crust. Okay. The sudden shifting of land masses. Sudden shifting means going one place to another place, cause upheavals. Upheavals means sudden big change in the crust of the earth, sending vibrations. Okay. So, the sudden shifting the land mass, it is sending the vibrations or waves into the surrounding portions of the earth. Okay. So, the sudden shifting of land masses, the plates tectonics move, sudden changes, sudden movement, it create a vibrations, the waves, it create a vibrations and waves surrounding the portions of the earth. Okay. The waves sent in all directions of the earth crust. Okay. It is the another cause, and sometimes the surface of the earth itself cracks. Sometimes the surface of the earth itself cracks. Cracks means it break itself. Okay. Another cause of the earthquake is volcanic eruptions. Another cause of the earthquake is volcanic eruptions. A violent explosive eruption. Okay. The explosive eruption. Okay. Sudden bursting of the volcanic. Sudden bursting. Okay. It create the it produce the earthquakes on the nearing areas. Okay. Sudden bursting of volcanic eruptions. Eruptions means bursting. Okay. Explosive eruptions often cause the earth in its vicinity. Vicinity means nearing areas to quake. Earthquake are often common in most volcanic areas. Okay. So, earthquake is most common in volcanic areas. Okay. So, the sudden explosive eruptions, it produce the earthquakes on the nearing areas of volcanoes. Okay. The instrument to measure the earthquake is called seismograph or seismometer, and science deals with the earthquake is called seismology. Effects of earthquakes. Earthquakes may cause changes on the surface of the earth. Vibrations often set landslides in the mountain regions. Okay. So, in the mountain regions during the time of earthquake, landslides may be caused. A greater danger in the earthquake is the falling of building. A greater danger in an earthquake is falling of the buildings. Most of the houses which collapsed were made of mud and bricks and proved to be a death traps. Okay. So, most of the houses which collapsed were made of mud and bricks and proved to be a death traps. Fire is another great danger. Underground water system is naturally disturbed by such movement. And another most important effect of the earthquake is tsunami. Okay. So, the earthquake movement on the sea floor or nearing the below the sea floor or near the sea, it causes a huge waves, huge and large waves. Okay. So, it is another most dangerous waves. It disturbs and it destroys the life and property in huge level, sometimes more than the earthquakes. Okay. Yes, tsunami is a Japanese term. It is the meaning of harbor waves, the huge waves caused in the sea by an earthquake. Tsunami are quite common along the coast of Japan and other regions in the Pacific Ocean. Okay. So, another important effect of the earthquake is tsunami. An earthquake which below or near the sea causes a great disturbance in the water. Okay. The earthquake on the below the sea or nearing the sea floor, it a great disturbance in the water. The floods and waves caused great loss of life and property, sometimes more than the earthquakes. Okay. Tsunami is a Japanese term. It is the meaning harbor waves, huge waves caused in the sea by an earthquake. Huge waves caused in the sea by the earthquakes. Tsunami are quite common along the coast of Japan and other regions in the Pacific Ocean. Okay. In the year 2004, Indian Ocean is affected by earthquake. During that time, a great tsunami caused in this region. 280,000 people lost their lives, and it is the 6th deadliest disaster in the world. Okay. Do you clear? Now we are going to see distribution of earthquakes. Most earthquakes and volcanic eruptions do not strike randomly. Okay. Most earthquakes and volcanic eruptions do not strike randomly but occur along the plate boundaries. It occurs along the plate boundaries. Okay. One such area is the Pacific Ring of Fire. One such area is Pacific Ring of Fire. The Pacific Ring of Fire, the Pacific plates meets many surrounding plates, where the Pacific Ocean is the biggest water body in the world, largest water body in the world. So, the Pacific sea floor meets many surrounding plates, that is the main region for the earthquakes and volcanic eruptions. Okay. One such area is the Pacific Ring of Fire, where the Pacific plates meets many surrounding plates. The Ring of Fire most seismically and volcanically active zone in the world. The other zones are mid-oceanic ridges, mid-continental belts. Okay. In India, Himalayan regions, Ganga Brahmaputra valleys are the zones of the earthquake. Number of earthquakes have been experienced in this region, Himalayan regions and Ganga Brahmaputra valleys. Do you clear? Seeing next video, it will helpful for you a better understanding. today's your assignment is what is an earthquake and how it occur. What is an earthquake and how it occur? Mention the types of seismic waves. Mention the types of seismic waves. Write about Pacific Ring of Fire. Next video we will see volcanoes. Thank you students.
What just happened? Did we just experience an earthquake? But why does this happen and what exactly is an earthquake? Earthquakes are caused by the release of energy that generate waves which travel in all directions, causing the shaking of Earth's surface. What exactly is this energy? What waves? What's shaking of Earth's surface? This is so complicated. Well, calm down. Let me explain everything in a simple and detailed manner. Earth is not just one piece. It is made up of jigsaw puzzles of around 19 to 20 pieces which are called as tectonic plates. These plates are placed on a hot, partially molten layer of Earth's mantle. This is the reason why these pieces are continuously moving. They are moving as you are watching this video. These plates move around 1 to 10 cm each year. But don't worry, not all these movements can be felt by us. Sometimes these movements are extremely strong and can be felt like a lot of vibrations under your feet. Or it can also destroy an entire city. That's called an earthquake. The earthquakes occurs in the lithosphere region of the earth. An earthquake generates underneath the earth and this releases the energy across. The point at which the earthquake occurs under the earth is called hypocenter and the exact place above it at the surface of the earth is called epicenter. The most horrifying earthquake recorded till date was of magnitude 9.5 out of 10. This happened in Valdivia in southern Chile in 1960. Another one that happened in Japan in Tohoku region was of magnitude of 9.0, which happened on March 11, 2011. This earthquake caused massive and enormous damage and destruction and took nearly 16,000 people's life with him. Geologists use a device that can sense the waves created by the movement of the tectonic plates. These waves are known as seismic waves and the device is called as seismograph. The earthquake events are scaled according to magnitude of the shock and are known as Richter scale. This magnitude relates to energy released during the earthquake. Magnitude is expressed in absolute number 0 to 10, where 0 is lowest, where people feel nothing, and 10 being the highest that can create severe destruction and loss of life over a large. In order to know more about earthquake, let's jump to the simulator. We can see on the screen is the inner core of the earth. And then we have outer core, mantle and crust. The inner core, as the name suggests, is the innermost layer or the central layer of Earth. It is like a solid spherical ball in nature with a radius of 1250 kilometers. The temperature of Earth's core ranges between 4500 to 5500 degrees Celsius, facing a pressure of 300 to 360 gigapascals. Next is outer core. It is of about 2200 kilometer thickness and has a temperature similar to inner core, that is of 4500 to 5500 degrees Celsius. Then we have the mantle layer, which is the semi-solid state of about 2900 kilometer thickness. This layer makes around 84% of Earth's total volume. And the last layer is the crust. which is like an apple's skin when compared to other layers, runs from 0 to 70 kilometers in thickness, which is specifically 8 kilometers under sea to 32 kilometers under continents, and this is only 1% of the Earth's total mass. Now we can see that there's a grayish white dot. Let's click on that. We can see a small town when we see this in the street view, and then when we click on layers view, we can see Earth's layer. The grayish in color is called as crust, and the one in reddish color is called as mantle. On the left hand corner side, we can see we have a small box that says earthquake magnitude on Richter scale with 3 buttons that shows the magnitude of the earthquake. If the intensity is between 0 to 2, it can be barely sensed. When the intensity is more than 2 and less than 4, we can feel minor vibrations and sense it a little. From 4 to 4.9, it is considered as small or a light earthquake. Range from 5 to 5.9 are considered moderate earthquakes, and from the range 6 to 6.9 are considered as strong earthquakes. In some time, we will see how much damage these magnitudes can do. And anything above 7 is considered as major earthquakes, which can destroy cities and continents. These readings are recorded on a seismograph. Now, let's hit the 4 to 4.9 magnitude to see how this earthquake happens. We can see the earthquake starts from a point called a hypocenter inside the earth. During an earthquake, 2 types of waves are formed. One is called body waves and the other are called as surface waves. Let's see what are called as body waves. Body waves are the waves that move through the interior of the earth and through the body of the earth, and hence the name. When these body waves move, these waves come across the surface rocks and generate the surface waves. Let's see in detail about these body waves and surface waves. From this point, that is hypocenter, waves are released. These waves are called primary waves or P waves. Now, what are these P waves? P waves are seismic waves that shakes the ground back and forth in the same direction and the opposite direction as the direction of the wave is moving, which is similar to the movement of the sound waves. This is how a P wave looks like. These P waves are the first to be recorded on a seismograph. Now, after a fraction of a second, when these P waves hit the rocks closer to the surface, gives rise to a new set of waves, the S waves, or called as secondary waves. These waves are towards the earth crust, and these are tremors and vibrations that we feel. S waves are the wave motion in a solid medium where the medium moves perpendicular to the direction of the wave. After the P wave, these S waves are recorded on a seismograph. Now these S waves hits the surface and starts the earthquake. The point at which the earthquake originates on the surface is called an epicenter. After the P and S waves comes the surface waves, which are the most destructive waves as they cause the movement or the displacement of the rocks, which leads to falling of structures and causing harm to life. Let's once again see the formation of P and S waves. We can see that an earthquake of this magnitude, that is between 4 to 4.9, causes the damage to nearby small houses, but the buildings are okay. Let's see what happens when the magnitude is between 5 to 5.9. Let's reset and then hit the button. Whoa, that's quite some damage. The small houses are shattered and the buildings also have cracks. We can also see that the road is also cracked now. One more thing to notice is that the higher the magnitude, the closer the hypocenter is to the epicenter. Notice this when we move to 6 to 6.9 magnitude. The damage is enormous. Buildings are almost broken, roads are cracked, and small houses are collapsed. Earthquakes can really be extremely damaging natural calamity. If this is the case when magnitude is limited to 7, imagine how 9 and 9.5 might even look. Since these are quite commonly occurring magnitudes, we have studied them in this simulation. It is extremely difficult to predict an earthquake based on a seismograph, which is also known as seismometer. But even our smartphones can now detect these seismic waves, and scientists can use this data to predict earthquake and warn people. NASA can use this information in the QuakeSim software, which can use this data to generate more efficient information. Recent studies showed that before an earthquake, nearby regions record very high concentrations of radioactive pair, radon and thoron. This happens because right before the earthquake, these gases are released on the surface from small cracks, and if we can detect these gases, we can predict a quake at least 7 days in advance. Well, here are some tips that can save you in case of an earthquake. Till then, keep yourself safe and see you in the next session. Well, I hope you have enjoyed this session. This session is based on an interactive 3D simulation called Scholar, developed by Escavel. Visit www.escavel.in to request the download of the software application to try this out yourselves. If you have enjoyed this video, hit the like button. If you have any queries, comment down, and yes, don't forget to hit the bell icon and never miss another update from Let's Tute. Keep watching, keep learning, and follow your curiosity. Thank you.